Right. So I'm going to go back and review one more time how you examine asymmetrical costs for your classifications, right? And this is the example that we saw. You have the actual data, 1,000 people, actual zeros are 990, actual 1 is 10. So 1 is the event of interest. Okay. So I have a new file here, and okay, go ahead and download that. Okay, sh2. Okay. This is an Excel file. So I'm going to work through the problem so you'll have an example to fall back to when you're doing the test. Okay. So actual class is either 0 or 1. Okay, and we know by examining the data we have there are totally 1,000 and 990 are zeros and one person there are 10 ones. So using the naive classifier just simply classifies everything as the most prevalent class. So it will be that 0 is the most prevalent class. So it's going to classify everything as 0, right? Because that's the most prevalent class. So your classification matrix will look like this. And your misclassification rate or error rate then is that, okay, that plus that divided by that. Okay. So 1% error rate. Now we are going to compare that against some data mining technique. Okay. Suppose if some data mining technique uses a different set of classification, you still have, so that's your original data. Okay. That's still the case, right? But suppose if so the off diagonal, sum of off diagonal divided by the total. Okay, that's your misclassification rate or error rate. Okay. Now this data mining technique, okay, so it classifies, okay, not all of them as zeros, okay, the most prevalent class. Instead, it classifies it classifies 28 of them as belonging to class 1 and the remaining as class 0. Okay, so I'm just making this up. Okay, some methodology, and it turned out this way. And here we have 8 of them were actual ones. So 20 of them were not. So then we have 970 and 2. So your misclassification rate is 2.2%, and that's why, you know, if you go by misclassification rate, then naive model looks better because it has only 1% misclassification rate. But if we have asymmetric cost, that is the net profit from actual ones is $10 and cost of making an offer is $1, which is the example that we saw. If you classify everything as 0, I mean if it is naive, everything is 0, then you're not going to make any profit at all anywhere, right? So you're predicting everything as 0, so you're not getting any profit, and all the ones, you're not predicting anything as 1, so there is no profit coming from there. So your net profit is the sum of all those. Okay, so 0. All right. Now, but in the case of the data mining, everything that you the 972 that you predicted as 0, you're not getting anything because you're not making an attempt. There is no profit coming from them. All right. Now, of the 28 that you predicted as 1, okay, so these people, 20 of them, you would have spent $1, right? So I need to put a minus sign in front. So your profit is going to be minus 20. You're not getting anything back, right? But from these 8 people who are actual ones, okay, of the 28, 20 were false positive. 8 are true positive, and they will give you a profit of $10 each. So your net profit then is $60. Now, based on this analysis, then you see that this data mining method is better than naive method because 0 profit against $60 profit. Okay. So the classifier here, okay, the classifier has the $60 net profit. Okay, misclassification rate for the classifier is 2.2%. Now we can do the same computation from a different perspective, that is the opportunity cost perspective, where you look at only costs in all the possibilities, including opportunity lost. So this cost matrix. So if you have true negative, okay, there is no cost at all. You've not contacted them, you've not spent any money on them, and you have not lost the opportunity to make any profit out of them. So 0. Whereas if it is false negative, so it was 1, but you predicted them as 0, so you lost $10. Remember, the opportunity cost matrix, everything is cost. So all the numbers are positive. You cannot have a negative number in opportunity cost matrix. Okay. So $10 loss here. All the ones that you're predicting as 1, the cost is just $1 each, because you would make an offer which costs $1. Okay. So this is the opportunity cost matrix, or per case, per individual. So now let's compute the cost for naive and data mining. Okay, so here, how many in each cell? So all you have to do is to multiply how many people are in each cell, multiplied by the corresponding cost of that cell. Okay, so now when you sum, you get the cost. You do the same here. Okay, so these are the numbers in the classification matrix times the cost. So that's your opportunity cost matrix right there. And okay. sum that and get an opportunity cost of $48 against $100, and obviously $48 is much better than $100 cost. Okay, so this is what we did. I just went over the slides. I didn't work it out, so I thought I'll work it out so you'll have an example of it.